Good day, ladies and gentlemen. This is Sarah van Grenen, aka Mr. VG, and this is such a wonderful, amazing day because we are starting with the proper matric work, calculus. This is part of a series of exam preparation videos for our matriculants where we are looking at all the different topics in your exam. Okay? When we look at all the different topics in your exam, ladies and gentlemen, this is now the second last one in your matric paper 1, calculus. Also one of the biggies. We are talking about an easy 30% of your exam paper. So calculus is not a very difficult section of work. But the implications, the application of calculus is so far-fetching that it can go into all the different aspects of your life. And I'm not exaggerating, I really mean it. So looking at question 9 in your grade 12 November exam of 2021, it consists firstly of a straightforward derivative question. Hit the pause button at this moment of time and try it yourself. Then play and look how I do it. When looking at something like these questions, I'm first of all going to get stuck in to question 9.1. It says they determine f accent x from first principles. So I know I've got to use those first principles. That's the only formula you have in calculus. So go for it. Substitute first of all f of x plus h. I love to now replace every x with x plus h and simplify as far as possible. So x plus h squared is x plus h times x plus h. I'm going to multiply out those brackets, x squared plus xh plus xh plus h squared, adding the middle terms and multiplying out my brackets. Now that is in simplified form. Remember, ladies and gentlemen, that is now f of x plus h. When we look at substituting into the formula, I'm going to substitute my fx plus h into that part of the formula. Let me just erase this fx plus h here to make a bit of space. Then I'm going to substitute that minus fx. Remember that then goes into there, into fx. I'm going to now simplify as far as possible. So this means multiplying out that back bracket. So I'm distributing the minus into it, adding and subtracting the like terms, which leads me to that expression. I still can't make h 0. Remember, that is what the limit as h approaches 0 is all about. It is getting to a point where I can make h 0. So I'm going to first take out a common h. Yay! The h's cancel out. They divide away. Actually, I hate the word cancelling out. They divide away, leaving me with 4x plus 2h minus 3. I have to ask myself this now. Can I make h 0? In other words, is there something, if I make h 0, that is either non-real or undefined? Non-real being a negative under the square root, or undefined, am I dividing by 0? No, so I can now replace h with 0. leaving me with an expression of 4x minus 3. A few things before I move on that you have to understand. This is 5 score marks, ladies and gentlemen. Really, 5 score marks. Please make sure that you don't make silly mistakes. What silly mistakes have I seen my students make? They first of all make mistakes with f of x plus h, replacing every x with x plus h. Secondly, they forget that there's an f accent x on the left-hand side. They put zeros there, or I don't know what other things they put there, but they forget that. They also, my students, write the limit as h approaches 0 on the left of the equal. No. It must be on the right-hand side. So please make sure that your h approaching 0 is on the right-hand side. There. And I write it over and over and over again until the point where I can make h0. Your teacher in the prelim exam can stop marking if you leave out the limit at the wrong place. So keep on writing it until you make h0. Your teacher can also stop marking if you don't write f accent x on the left. So actually, if I were you, I would go and write f accent x every single time on the left until the final answer. Every single time. So you don't forget about it. I know it's a bit of extra work, but ladies and gents, that's 5% of your exam. Doesn't maybe seem like a lot, but 5% is about 3 marks, 3 to 4 marks in your exam. Don't make silly mistakes. You will get one question like this, so make sure you answer this correctly. Let's have a look at the next question, okay? The next question, ladies and gents, okay, actually requires us to do to throw away first principles. I say throw away, I just mean more. You need the short method derivatives. So before we go to the next question, let's make sure that my previous answer is correct. If I've got fx equal to 2x squared minus 3x, and they just say determine f accent x. So no first principles, just f accent x. This is my test, this one. Please understand, this is a test. So if I look at this, I'm first of all going to remember, that did not come out right, okay? So if I look at this test, I'm going to start by writing the short method derivative rules. If I've got fx and I want to derive, so ax to the n, remember the n goes to the front and I subtract 1 at the exponent. The second rule says, if I've got y equal to a of x, as if it is a straight line, dy over dx is simply the gradient of your straight line, because derivative means gradient at a point. So the gradient of ax is just a. Lastly, ladies and gentlemen, if I've got a constant value and I'm deriving it in terms of x, the answer is 0. Why is that? The reason why that is because derivatives means rates of change at a point. A constant cannot change. So the rate of change is 0. So if I look at fx and I do f accent x, I'm going to bring the 2 to the front for the first one and subtract 1 at your exponent. Same with the second term. I'm going to bring the 1 to the front and subtract 1 at the exponent, leaving me with 4x minus 3, which is exactly what I got there. So I know that my answer is correct. Ladies and gentlemen, I always like to do this as a test to see whether my answers for first principle derivatives is right. Let's have a look now at question 9.2. Now question 9.2 is just straightforward derivatives. First of all, we need to have a look, can I actually derive every term of the first question 9.2.1? How do I know whether I can derive it? Remember, there are 3 restrictions. Roots, x's in the denominator, as well as brackets. So the first term is just 4x to the 5, so I can derive it, as well as the second one, as well as the third one. Which means I can straight off jump into my derivatives by saying the first term is take the 5 to the front, so 4 times 5, x to the 5 minus 1. Same with the second expression, 6 times 4, x to the 4 minus 1. And that last one is basically ax. So I'm just going to be left with 3. Just simplifying my answer, I get 20x to the 4 minus 24x to the 3 plus 3. Boom, wham, bam, thank you, ma'am. I am happy with that. But the second one, remember that dx means differentiate in terms of x. So x is your variable. First of all, let's look at the first expression. That x is innerst root. So I cannot get that, or in a surd. Surd is better. That's a more mathematical term, in a surd. In the second expression, I've got 2 problems. First of all, I've got the x in the denominator, and actually that square for the brackets. So there's a lot of issues in the second one that I must first handle before I can actually calculate dx or evaluate dx. So for me to evaluate dx, I must remember the basic exponential rules. First of all, if I have an x to the a inside an nth root, the exponential rule says that it's the same as x to the a divided by n, or over n. As well, I need the exponential rule that says if I've got 1 over x to the a, it's x to the negative a. Those are the 2 rules that I need for this expression. So I'm going to still write dx. Okay? So writing the cube root of x as being x to the power of 1 over 3, and then multiplying out the square at the back bracket gives me 9x squared, because it's 1 squared, 3 squared, x squared. Still, I cannot derive that. So I'm going to write my dx again. Look at my way of writing. The dx just remains in the front the whole time until I'm actually ready to derive this. So taking that x to the power of 2 to the top, I make the exponent negative. Why do I write the x to the third next to the half? Well, where does the half actually come from? Remember, there's a 1 in the front there, and there's a 2 in the denominator. So 1 over 2, x to the power of a third. I like to write it like this, simply because my rules I can apply better now. Am I in the position to now derive? Well, the first term, yes. The second term, yes, because I don't have surds or x's in surds, and I don't have negative exponents, or I don't have an x in the denominator. My apologies, I have a negative exponent. I don't have an x in the denominator. That means that I can apply the derivative rule for the first one. So the third comes to the front, and I subtract 1 at the exponent. As well as at the second expression, I multiply by the negative 2, and I subtract 1 at the exponent. You don't have to write this part in. I like to write it in so you guys don't think I'm just doing magic, although maths is magic sometimes. I'm multiplying my exponents, and just as a final ode to mathematics, I love to write my exponents as positives. So I'm going to take the x to the negative 2/3 to the denominator, and I'm going to take the x to the negative 3 into the denominator. Now you might ask, do I have to? It depends on your teacher. Okay? In an exam, I would always do that because you don't know who's going to actually mark your final exam. And in grade 9, we taught you never leave an answer with a negative exponent. So I love to write that as my final answer. But remember, ladies and gents, if you don't write it as your final answer, in other words, you write it like this, your teacher may deduct 1 mark. But some teachers are going to say it's fine. In my final exam, I would write it like that. Whoa, this was fun. Lots and lots of fun. In our next video, ladies and gentlemen, we're going to move over to now the biggest application of derivatives, which is graphs and functions. That is the biggest application, the one that counts the most marks in calculus. So this is Mr. VG signing out. Have a gorgeous, amazing, wonderful rest of your day. Please keep yourself safe and study really hard. Give it everything this next 4 months, and you will achieve the marks that you are capable of. So keep well, push hard, cheers.